Alright, here we go. May 2015, Paper 2, Time Zone 2, Question 5. F of x is e to the x plus 1 plus 2, and we're defined over the range of the domain x from -4 to 1 inclusive. Sketch the graph of f. Well, it's an exponential graph. You can do these pretty easily anyway. But let's go ahead and, where'd that go? Let's go ahead and use our calculators. It's a calculator exam. Make the most of it here. So we have e to the power of x plus 1. Close the bracket there. What else do we have to do with that? We have to add 2. Let's have a look at that, but before we do, let's set up our window so it looks the same as those. So the x values are going from -4 to 4 with a scale of 1. Very good. The y minimum in this case is -1, and we're going up to the massive, huge value of 10. We've now got the same graph. We get a good idea of what it looks like. What sort of equation is this? Exponential, been shifted up to. What does that mean when I go to draw it? It means that we've got an asymptote, doesn't it? Usually exponentials are asymptotic to the x-axis, but we've shifted up to. So let's start by giving ourselves that reference point, and there's the asymptote at y equals 2. What other things are we going to need to do just to make sure we've got a bit of an idea? Find a few values. Let's g-solve for the y-intercept, and that's 4.718. So you come over to your thing and you go, there's about 4.5, 4.718 is about there. Or I always tend to, when I'm trying to do these delicate ones, be a bit soft and just hang on there too long. Sorry about that. There we go, that'll do. Now we're only going up to 1, so when x equals 1, let's do a g-solve here. And we want to calculate the y when x equals 1. The value is 9.389, so 9.39. There you go. So that's ending there at 1, 9.39 to 3 significant figures. And we better have that starting point as well, hey? So shift g-solve. Let's calculate the y value when x is -4. That was our left hand end of the domain. 2.0497, so about 2.05. So I'm going to put a dot there, indicate that it stops there, and of course every time I do a dot, now you'll hopefully be doing this where your arrow doesn't cross over it. But there you go, so that's the point there, -4, 2.05. I've got 3 points that it's going through, so typical exponential function in shape. You would do a better job of that than I will on my paper, there, because you'll be doing it on paper, but you get the idea. Make sure you indicate that it stops there. It's just going to keep doing that, isn't it? There we go. There we go. Make sure it doesn't look like an open circle. Closed circle. We can even put in that y-intercept. Now, if you did this for your y-intercept, that's going to look a little bit bad if you actually got it through there. So it's always, you want to show what point it's going through. So I'm just going to actually label where I wanted it to go. So particularly if you have a little bit of trouble with your writing, or you're doing it in pencil and it didn't work too well and you can't rub it out, whatever, just make sure you let them know you know exactly where it goes. 4.72 is what I want to write there. They'll have a little bit of tolerance. It'll usually be around that mark. You can see them a bit below. Because I've labelled it, they would be happy with that, and I'll be fine. There you go, there's a sketch. Graph is translated by a vector 3 and -1. Now I'm going to need to see the equation, so I'll do the working up the top here. So for part B, if f of x equaled e to the x plus 1 plus 2, and I want to have g of x now to translate horizontally 3 units to the right. What am I going to do? I'm going to go and subtract 3 from x. Remember, adding or subtracting to x has a horizontal shift, and to shift vertically down 1 after my plus 2, I'm going to subtract 1. So g of x is simply e to the power of x minus 3 plus 1. That's x take 2. Plus 2 minus 1 is plus 1. And you are done. Alright, that's question 5. You could, if you wanted to, have a little look at that and make sure it looks like it's been shifted in the right direction. e to the power of, and we are now going with not with x plus 1, but x minus 2, x minus 2, bracket, and then we want a plus 1. What does that look like? Yeah, that looks pretty much like it shifted 3 to the right and down 1 to me. So that's looking pretty good. Alright, pretty confident we got it right. See you in question 6. Bye.